Hello everybody. Today topic is the structure of the computer. Before we go for the structure of the computer, I would like to tell you that a computer has the central unit named microprocessor. Microprocessor actually named microprocessor pretty recent because 10, 20, 30 years ago, microprocessor was macroprocessor. It was huge devices that take the room like a classroom for the computer. But now it's microchip, it is, and microelectronics actually make new computers very small as a handheld. So microprocessor. Let's go for microprocessor and I will make the chip of microprocessor. Microprocessor. But microprocessor doesn't have any brain and it has no knowledge of what to do and how to do. It can only manipulate with storage and fast storing device, which is memory. So folks, what is memory, computer memory? I will go for drawing this long rectangle, this computer memory. This is computer memory. Computer memory is a binary device, so it has so-called cells, and I will draw these cells. So it looks like a binary table. And if you ask me what the nature of this little cell, so I will draw the cell structure here, and you will be able to see that a cell contains bytes. In this case, there are 4 bytes, so this is 32-bit. 32-bit, 4 bytes. But folks, in more expensive contemporary computers, that could be 64-bit. So that will be a longer cell, which has 8 bytes and 64-bit. Every little section here is 1 byte. 1 byte is 8-bit. So, folks, this is memory cells. How many of memory cells? I will tell you that usually for the good computer now, it could be 32 gigabyte of total amount of memory. And memory, computer memory, has the number for each cell. So I'll put here number, and could be 1, 2, 3, 4, 5, 6, 7, and so on and so on. Definitely these numbers must be converted to binary code, and binary numbers for the cells named address. Address. So every cell has its own address. What we can put in this cell, what microprocessor can put in this cell. We know that we can put here the alphanumeric information. For 64-bit, we can put 8 letters. For example, mommy, that is 5, and 3 more, dash, I, go. Or we can put binary code like this, 10011011101. The purpose of binary code is different. Binary code could be just digits, or binary code could be letters if we're going for encoding, ASCII code, American Standard Code for informational interchange, or Unicode for internet. So this is content of the memory. Part of the memory could be data. What kind of data? Folks, for example, you need to calculate formula x is equal a squared plus b. To calculate this, you need to know what is 8, what is b. So a and b must be inputted into the cells in a Metaphor microprocessor. Calculate this formula. We will see a little later how microprocessor can calculate it. Then part of the memory, significant part of the memory, could be a program. Programs. What is programs? It's a set of instructions for microprocessor which actually could be placed and is placed in the same memory but with a different address. And one of the permanent resident in a memory is operating system. Operating system, folks, is residential program that create interface between user and computer. So now we understand what memory is. The speed of memory, the reading or writing inside of the memory, is about of 6 nanosecond. 6 nanosecond. 1 nanosecond, it is 10 of minus 9 of second. So that is it's 1 billion part of the second. So this is a very small fraction of the second. So I can tell you that memory is extremely fast, and its speed and velocity comparable to the microprocessor. But microprocessor can work with different devices. And I will tell you guys that memory is power dependable. Power. It needs power. When you use laptop, it's powered by the battery. When you use desktop, it's powered by the outlet. It's power source. So when power is lost power lost, memory will be zeroed, all zeros. So we need to keep memory powered. But our computer actually sometimes need to be turned off. And to turn it off, we need to save what actually processor made during this time of working. And in this case, we will go for the device that named storage. Storage device, folks, could be hard drive or solid state drive, or it could be flash drives, but the storage is when you turn power off, the storage still remain filled with information that you put there. So it's power independent. To make microprocessor to work with all of these devices, because storage is slow comparing with memory, we need to put some kind of middleman. Middleman, folks, is the device that actually use microprocessor use it, and memory and all use it as a secretary. So the device named bus. Bus, folks, It's informational transportation device. It's transporting information from microprocessor to other different devices. So how the work between microprocessor and memory and storage looks like in this case. Microprocessor send message to the bus. Definitely its message is binary and digital. Bus, I need to read a certain memory cell. Then bus send message to memory. For example, this is cell number 8. And bus send message to memory. Can you prepare cell number 8 for reading to microprocessor? And I will put cell number 8. It is bits of the cell number 8. I will tell you that microprocessor has extra operative memory, so he or it can memorize the content of memory cell. And then memory said, I'm ready to send you content of my cell number 8. Then bus said, send it to me. And memory sent it. Then bus called microprocessor. Microprocessor, sir, can you receive what you requested? Memory cell? Microprocessor, yes, send it to me. And then bus will send it to microprocessor. Definitely this connection is bidirectional. The same, folks, I'll put double arrowed connection line that actually bus connected to storage device. Storage device could be hard drive or SSD. Okay, solid state drive. Solid state drive doesn't have mechanical parts. So this computer already can function, but we need to connect it to external world. So for this, I will go and connect it to keyboard. Keyboard, you know, this is famous input device that is connected to bus, and this is keyboard. And when we're working with computer, we need to have the screen, and that is monitor. Folks, monitor is just kind of flat TV, but it works with the images. But computer works with the digital arithmetics, with binary code. So to convert binary code to the code of TV, we need conversion device, and that is output device. This device named VGA, Visual Graphic Adapter. So it converts binary code of the memory and processor to the image that being shown on the monitor. So keyboard is input device, storage device is input and output, memory input and output altogether, and microprocessor is input and output. What else we need as input device? As input device must be mouse. Mouse is cursor motion device that actually control the position of cursor, and mouse has certain logic. We will speak about it later. Okay. Big computers usually have the disk drive, and that could be bidirectional disk drive, which could be CD compact disc, or DVD video disc, or even Blu-ray disc, BD. And I'll put here slot to put disc in. Contemporary computers allows you to record these discs. But what else I need? I believe I need output device that will connect our computer to network. And then I'll put it here, and I will move the line here, and this line is bidirectional. And then I will put here so-called network adapter. A network adapter could be connected to modem. Modem folks, it's modulator, demodulator, modulator, demodulator, which actually connected to the coaxial or optical informational line that coming from